Hi everyone. So we're going to go ahead and take a look at a system of equations here. We solved it by graphing before. So if you take a look here, at what point, if you guys can type in the chat, at what point do these lines both meet? What is the solution for these two lines? Solving a system equation, I have a line going up, a line going down. At what point do they meet? I'm seeing a lot of people saying 1, 3. Would you guys agree that 1, 3, if I'm at 1, or at 1 and up to 3, and that is the correct answer. Great job. Okay, and that is right. So we have a solution here by looking at the graph. It's 1, 3. Thanks for participating. Now, let's take a look at the original equations though. If I look at the original equations I wrote here are 2x plus 1 and negative x plus 4. Now, us graphing something to solve it is not that bad when it comes to us graphing stuff on the computer. Graphing a line on the computer is super easy, okay? And it's always super accurate because the computer is doing most of the work. We're just kind of plotting the two dots. Today what we're going to work on is we're going to solve this equation algebraically using something called substitution. So let's go ahead and rewrite this. 2x plus 1 and negative x plus 4. Y is equal to 2x plus 1 and y is equal to negative x plus 4. And we are going to solve this algebraically, meaning we're going to solve this not by graphing, but by plugging in the numbers together. And today we're going to work on the skill called substitution. And what is substitution? It's replacing one thing for another. We're going to substitute one thing for another. And it's a very general way of saying we're going to start plugging in whatever we got. Anyone ever make a spaghetti sauce before? And you start off with tomatoes, right? And then you start looking in your fridge and you kind of throw in whatever you got. We're going to plug in some onions, some mushroom, some oregano, maybe some tomato paste to make it a little thicker. So in this case, we're going to choose what could we plug in? What could we substitute? Because sometimes you're missing something and you have to switch it with something else. And in this case, we are going to substitute our variables for each other. So take a look here. If I sound like I'm repeating, I kind of am. But let me say this. What's y? Y is equal to 2x plus 1, right? But y is also negative x plus 4. Y is 2x plus 1, but y is also negative x plus 4. And in substitution, we're saying, hey, isn't y equal to y? Can we plug y for y? Now, we've done substitution before, where I ask you guys to plug in x. Let's say x is 3, x is 2. We can plug that in. But in this case, we're going to plug in equation for equation. If y equals to 2x plus 1 is equal to y, right? I just flip that around. But isn't y also negative x plus 4? Salt. Isn't y equal to negative x plus 4? So what we're going to do is we're going to write 2x plus 1 is equal to negative x plus 4. And the reason why we're doing this is because in algebra, we can't solve something if there's two variables. But if it's only one variable and we can change it so we only see one variable in the problem, we can solve that problem. We can say x is equal to something, y is equal to something. But if it's two variable, it's almost like you're wrestling with someone. If I change, you change. If you change, I change. But if it's just you by yourself, hey, you can do whatever you want. So let's take a look at what I did here. I said I have two equations. See, there's two equations, and with two variables. And now when I substituted it, we end up with one equation and one variable. So we mix those two equations together, and we have one equation, one variable. Now let's go ahead and solve this like we typically would. I'm going to combine our variables together. I'm moving the x over here to the 2 side because I have more x's on this side. It's always easier to move the variables to the side with more x's first. We end up with 3x plus 1 equals to 4. I'm solving, now this looks just like our day 1 problems. Take a look here, 3x plus 1 equals to 4. That looks like a day 1 problem. What variable am I solving for? I've been solving for x. Let's go ahead and get rid of the 1. What's farthest away? 3x is equal to 3. How to get rid of a times 3? We're going to divide 3 to both sides. X equals to 1. Great. Now we kind of solved it. We said x is equal to 1. But don't we have originally in the problem x and y? Now here's the cool part. We got our x value is 1, right? That's our answer. Now let's go ahead and solve for the 3, okay? How do I end up solving for 3? Well, since we know x is 1, we're going to plug in, substitute x equals to 1 into y equals 2 equations, okay? So let's pick one. You get to choose. Do you guys want to choose to plug in the y equation 2x plus 1 or negative x plus 4? And the thing is, it doesn't matter which one you choose. They're both going to work because remember we mentioned that this is the point where they share in common. So whether you plug 1 into 2x plus 1 or 1 into negative x plus 4, they're going to give us the same answer. Okay? So let's plug into 2x plus 1 and we'll see what happens. So y is equal to 2 times x plus 1. Okay? And we said x was 1. Y is equal to 2 plus 1 equals to 3. Woo! That's what we said before. Y is equal to 3. What if I use my other equation, negative x plus 4? If I said x equals to 1 into y is equal to negative x plus 4, will it give us the same results? Y is equal to negative 1 plus 4. That is y is equal to negative 1 plus 4 is also 3. Yeah. So once we go back and we substitute, it doesn't matter which equation we use, they're both going to give us the same answer. Why? Because these lines meet at this one point, and that's the solution for the equation. Okay, let's do another question like this. Okay, I want to say y is equal to, let's do negative 2x plus 6 and y is equal to 2x plus 2. Okay. All right, let's find the solution. Find the solution with substitution. So this one's actually set up for us again, where we can just plug in one variable for the other. Y, hey, I can make the y's equal to each other because I want them to equal because I want them to have the same x and y point. So let's go ahead and substitute. If y is equal to, if 2x plus 6 is equal to y, right? Can we say y is substituting 2x plus 2? Because y is equal to y. Okay. For this problem, we have to combine, or just some things that we want to notice. We start off with two equations in two variables. Once I plug them in, we have one equation in one variable. Okay. And this takes us back to day one math, right? Where we're just solving for x again. There's no y in day one math. It's just solving for x. So let's go ahead and combine it. My question is here, do I want to move the positive 2x over to the left side or the negative 2x to the right side? For my hint is which side has more. It's almost like having a party. There's two parties going on. Are you going to bring people to the larger party or bring people to the smaller party? You want to bring people to the larger party. And thank you, Kyra. We want to move it to the right side because positive 2 is definitely bigger than a negative 2. Let's go ahead and move that over. The opposite of minus 2 here is a plus 2x to both sides because we're moving it to the right. And you notice that this actually totally becomes 0. Negative 2x plus 2x is 0. 6 is equal to 4x plus 2. Now this really is back to day 1 math. We minus 2 to both sides now. 4x is equal to, no darn, I'm sorry. 4 is equal to 4x. Then we divide 4 to both sides. Oh. X is equal to 1. All right, x is equal to 1, yay! Now that we solve for 1, we are not done because we've had variables x and y. Now again, you get to choose. Do you want to plug into the first or the second equation? I'm going to pick the second one. I don't have a minus sign. That seems easier to me. Y is equal to 2x plus 2. Y is equal to 1 plus 2. Y is equal to 2 plus 2 is 4. Okay, so y is equal to 4. So my solution for this problem is that is the point 1 comma 4. Okay, 1 comma 4. Now, is it always going to be this easy? Meh. I'll say yes and no. Substitutions are great if it's already set up for you. So I'm going to give you guys 2 more instances. One where it's easily set up for you, like you're practically done. And another where it's not done and you have to do a little bit of work. Okay, so let's go ahead and try this easy problem. Here's the easy one. Super easy. If I wrote x is equal to, let's say negative 7, and negative 7x plus 4y is equal to 9. Okay? All right, so this is our equation. If I wanted to graph, let's go ahead and show you me graphing this. I'm not saying that this should be the best way to do it, because if I didn't have a nice computer here, graphing would be a little bit of work, and it wouldn't be accurate. Okay, that's my first graph. Let me go ahead and show you my second graph. It's negative 7x plus 4y equals 9. Okay, so I want you guys to take a look at this. Where'd it go? That's right. X is, oh, sorry, it's over here. X is negative 7. How come this graph isn't showing? X equals to negative 7. There you go. It wasn't showing up. I don't know why. Okay. So can you guys kind of see where these graphs meet? They meet right here, and the answer is going to be negative 7, 10, right? So looking at the graph, kind of nice, obviously, that they meet at one place, negative 7, 10, negative 10. But what if I don't want to graph it? What if graphing takes too much work? Well, we have substitution. And here's the idea. X is equal to negative 7. X is equal to negative 7. X is equal to negative 7. So what's X equal to? X is equal to, we said, negative 7. So when it comes to substitution, we're going to substitute X equals to negative 7, because you told me X was negative 7, or at least I said X was negative 7. So X in this world will be negative 7. So when we plug in negative 7, you notice that now we have one variable, one equation. So let's just solve for y. 49 plus 4y is equal to 9. That's minus 49 to both sides, because we're solving for y. This is going to be negative 40, which is fine with me. Divide by 4, divide by 4. Y is equal to negative 10. Now that we solved for y, what did we say x was? Do we have to solve for x, or was that already solved for? Well, It was nicely already solved for here. So x is -7 and y is -10. And if you remember just a moment ago, this was actually the point where they met. So this is one of the easiest types of problems where it's already set up for you. And if you look at IXL, the first couple of them will be like this. So the goal today is not to graph, because if you had to graph by hand, you could be a little bit off or it'd be hard to find the point. But us using substitution and doing this algebraically, it's actually not that many steps. And it actually is pretty easy, especially if we're really good with solving for x or solving for y. Okay. We have one more method here I want to go over, and it's when they don't show up to be obvious. Okay, when it's a little bit harder, when it's not obviously substitution. Now here's the example. Okay, when nothing is not a good day type of problem. So if it's 3x minus 5y is equal to 11 and 4x plus y is equal to 8. So here is our example here, and we see that we have two equations with how many variables? I see an x and a y, two equations, two variables. But none of these say y is equal to automatically. It is not set up. It is not ready to go. So we're going to do some algebra work to prep it. Now, if you look at the top, I see 3x and I see 5. On the bottom, I see x and I see, hey, look, there's a y by itself, isn't there? So I could do substitution also here, whether I'm substituting x's or y's, as long as the variable is almost by itself, or it is by itself, we can actually save a lot of time. So you know what? I'm going to rewrite this as y is equal to. That's my goal. You pick an equation and solve y equals to or x is equal to. But in this case, we really want to use y is equal to. Why? Because we see a y. Hey, look, that's y is almost by itself. And you can do this with x or y and be flexible that way. So let's go ahead and change this. If I can move the 4x over, we have y is equal to, let me just show you the work. 4x plus y is 8. I'm going to minus 4x to both sides. Y is equal to negative 4x plus 8. Okay, so we have our nice magic equation here. And we're going to use this to substitute y in. We'll substitute y in. Okay, so we have our original equation up here, negative 3x minus 5y equals to 11. And we're going to substitute y in. Now, please be careful. It is 5 times y, right? It's 5 times y. 5 times y. Let's rewrite this as negative 3x minus 5 times y. Now, I'm going to include a parentheses because y is a big family, okay? Y is a big family. So y is negative 4x plus 8. Let me change the color here so you guys can see this a little better. Negative 4x plus 8. Y is a big family. So you need to write a parentheses. If you don't write a parentheses, not everyone is going to be multiplied by 5. And that's the one thing you want to realize, is that everyone's being multiplied by this 5 here, this negative 5 actually. So to get rid of the parentheses, oh, just as to make a note that I've been making a note, we went from two equations, two separate equations, and when we plugged them in, we end up with one equation and only one variable. And we only have a variable x left. Okay, so this method, we're going to multiply the negative 5 over. Careful. It's not just a positive 5, it's going to be a negative 5. So we're going to distribute the negative 5. Negative 3x plus 5 times 4. What's 5 times 4? That's 20. What's 5 times 8? That's going to be 40, negative 40, because it's a negative sign, equals to 11. So if you notice, when I plugged in the y is equal to, we substituted it. We only end up with one equation and one variable. But you still have to clean up now, right? It's a big mess. It's like your friend's giving you a huge box of presents. You open it, now you got to sort it. Make sure you have everything. We're going to combine these two together. I see negative 3x and a positive 2. Since they're on the same side, we say negative 3 plus 20 is 17x. There's no opposite operations here. We're just combining like terms. And now we're back to day 1 problems. Let's go ahead and move stuff around. We're going to plus 40 to both sides, plus 40. 17x is 40 plus 11 is 51. Almost done. The hint is I know this is divisible by 3. Oh, it becomes 3 because 3 times 7 is 21, and I see a 1 at the end. So divide by 17, divide by 17. X is equal to 3. Right, 3 times 10 is 30, 3 times 7 is 21, 30 plus 21 is 51, just to make sure. Right, 3 times 17, just in case you need to see this, is 30, and 21 is 51. Okay, just so you know that. Okay, now that we solved for x, are we done yet? Did we solve for the whole system? We've just solved for the x's. Let's go back and solve for the y's. Now, well, the cool thing is that we already have a y problem. We can say y is equal to negative 4x plus 8. If you give me your x, I'll give you your y's. If you want to plug into the other equation, sure, negative 3x minus 5y, you could do that too. But just a hint is that we've already solved for a y equation. So let's go ahead and plug it into this easy one. Y is equal to negative 4 times 3. Now, as you can see here, I'm showing a lot of work. And on the test, if you don't show the work, you can't get the credit because you really need to show all this work out. Negative 12 plus 8 is negative 4. Okay. So I have my answer 3 comma negative 4, where this is x is 3 and y is negative 4. But what if I want to double check? We could plug it in. Again, this is the way you double check your work. We can plug it in into the other equation I didn't use. I haven't used the negative 3x minus 5y equals to 11. Let's plug in negative 3x minus 5y equals to 11. Is that even possible? They're both negative. Let's go ahead and plug in our x's and y's. Our x's and our y's. Negative 9. Oh, let me just write it so you guys can see it. Negative 3 times 3 and negative 5 times negative 4. Does this become 11? Negative 9 plus 20. Yes, this is true. 11. 20 minus 9 is 11. Okay, so we can double check our work. Oh, my internet connection is unstable. That's not good. All right. So I want to also do one more thing. I want to go ahead and graph this for you guys to show that this would have been the right answer. Okay, so let's go ahead and copy these equations here. I have negative 3x minus 5y equals 11. And the next one is 4x plus y equals to 8. So if you want, you can practice using Desmos. I think that the link is in Schoology. And you see that the answer is 3, negative 4. Just to double check answers. That looks good to me. Hopefully that looks good to you. Now, if I had to graph this myself, it would have been a lot harder because even though this is in standard form, I can't find the roots easy. All the roots are fractions. And I would have solved for y, and it wouldn't have been nice and pretty. It would taken me a lot of work. Same thing for the other one. Actually, the other one, the roots are actually easy to graph. Okay, so graphing it would have taken me actually more work, I would say. At least me being accurate with my graph. Okay, now I have one more thing to say. So that's pretty much the main lesson. Now, why are we doing this? Is because we're going to build into word problems. And word problems are like the Mount Everest of math problems, right? It's hard for us to translate and to understand these word problems and to say, what do we do? How do we solve this? And I want to again reinforce that word problems are not just math problems, they're real life problems. In the real world, people don't give you equations like this and say, hey, solve it for me. Unless you're a physicist or like a guy that works at NASA, they don't give you equations to solve. They give you real life problems where they say, I have this situation and you have to come up with a solution. Your boss might say, I need 5 employees to work 6-hour shifts. Okay. Or maybe you're running a restaurant and you say, I need this many supplies. How much do I have to buy to meet demand? So these are real life problems. So let me go ahead and pull out one problem here today. Nope, not this one. Give me a moment. Okay, here's our first word problem. The question is, okay, let's read the directions. Write a system of equations to describe the situation below. Solve using substitution and fill in the blanks. Okay, so let's go ahead and read through this. A student council at Newport High School is making t-shirts to sell for a fundraiser at a price of $10 a piece. The costs, meanwhile, are $9 a piece plus a setup fee of $54. Okay, let's go and read that part again. A student council at Newport High School is making t-shirts to sell for a fundraiser at $10 a piece. So we know that they're selling t-shirts for $10 a piece. The cost, though, is $9 to make and a setup fee of $54. Whenever you make a t-shirt, I'm not sure if you guys have done this before, but they always charge you like a setup fee, whether it's like a design fee or for print screening, they have to buy materials to start this the print screen, silk screening. So they have a setup fee. Selling a certain number of shirts will allow the student council to cover their costs. How many shirts must be sold and what will their costs be? Okay, so these types of questions are kind of difficult to grasp. Do I have to sell 10 shirts? Do I have to sell 50 shirts? And then how much will it cost me in the end? But if I buy more shirts, it'll increase the cost. But if I don't buy enough shirts, I don't have enough money to cover the cost. Right? So it's kind of a back and forth. So as the number of shirts increase, so does the cost increase. So let's come up with a couple things we know. We know we're trying to sell these shirts, sell them, right? Oh, let's see if we can edit this. Actually, you know what? Let's go ahead and push this over, and I'm going to give us another view. Shrink that. It's too small now. Can I increase it? I can kind of increase it. Okay. So let's go ahead and take a look at our information that we do have here. We know we are selling t-shirts for $10 a piece. Right? We know they cost $9 per shirt plus a setup fee of, we said it was $54. Okay. And then we have two variables here. We want to figure out what, call it X, will be for the cost, for number of shirts. And Y is the cost overall. No profit. The profit is like $1, right? And again, this is a city council. Student council. So they don't make a lot of profit. They just want to make sure all these kids have shirts that when they sell it for this like promo. All right. So let's come up with our first equation. So if I buy 10 shirts, right? 10 times the number of shirts, that will end up with how much money we're going to make, right? I'm going to call this Y here. So if I make 50 shirts, I'm going to make $500. If I make 40 shirts, I'm going to make $400. So this equation here is how much I'm going to make. So this is our selling equation, okay? What is our cost equation? Well, the cost equation, it's for every shirt I buy, that's going to be $9. But then plus there's a $54 setup fee. And this will give us our total cost for that. So if we look at this equation, I wrote two equations here. The first equation was that I need us to figure out how much I'm going to make off these shirts. And that's the number of shirts, X, times $10. That gives me how much I'm going to make. The second equation, though, is how much it costs. The number of shirts I buy are $9 each, plus a setup fee. So if I buy one shirt, this is going to be $54 plus 9 would be $60-something dollars. But if I only sell one shirt, I'm only made $10. So we're not breaking even. So this is where system of equations come into play. I'm able to set up a situation in which I can solve for it because these Y values, we want them to be the same. We want our cost and our overall, not profit, but our overall money in, our selling money, to be equal to each other. So here's the cool part. Y is equal to Y. So 10 x is equal to 9x plus 54. And we can set them equal to each other to solve for the system of equation. That's minus 9 to both sides. X is equal to 54. That means we have to sell at least 54 shirts. Right? Now, how much would what would the cost be? Let's go ahead and plug it back in. Y is equal to negative 10x, right? Don't we have that easy equation? So y is equal to negative 10 times 54. Y is equal to negative 540. It's going to cost us $540. Okay, and that's when we break even. Okay. So we can see that we can use system of equations to solve for these type of word problems in real life. And if let's say you were running a business and you wanted to start up a business and you had to sell so many hot dogs or something, well, didn't you have to pay for the rent? Didn't you have to pay for the electricity? Didn't you have to pay for the workers? At a point, you have to sell so many hot dogs to break even and then to even make a profit. And these real life questions, real life problems are really where the money is. Imagine if you're the person who could figure out that formula. Right? Figure out how many you need to sell, find a problem, and be able to fix it using a little bit of math. Okay, all right.